Hello, hello. Welcome to this TouchDesigner tutorial on looping noise. It's the first part in what will be a series at looking at how to take noise and extract various types of loops from it. So this first one is based on a great write-up by Étienne Jacob, which is called Drawing from Noise and then Making Animated Loopy GIFs from There. And because I'm drawing directly on this tutorial that's focusing on processing, I thought it could be a good time to also look at how to sort of recreate something by looking at it, talking about that process a little bit as well. I think that often this is a really great way to kind of build techniques, is to look at something you find interesting and see if you can figure out how to make it using a different tool. So we'll be looking at this left one as the original looping GIF that he created, and we're going to be looking at how to create something similar in TouchDesigner. You know, it's a little bit different, but pretty much the same idea here. And we'll also be making sure that when this timeline hits, kind of like whatever your range is, we're going to have a seamless loop so that if you exported this as a GIF, it would start and stop in the same spot. So, you know, while TouchDesigner is a great tool for real-time video and animation, it's kind of the primary use for it. I do find myself creating animations from time to time that are fixed. So this is just kind of one tool you can have in that arsenal, is being able to you know, create video that loops. So we will go ahead and kind of start a fresh document and take it from there. All right, so here we are with a blank document, blank slate, and I'm going to go ahead and start by creating a box SOP. So we need some way of drawing those tiny white dots. There's a lot of ways to do this, but I'll use a box for this, and we're going to set it to 0.009 since we want these to be pretty tiny. So here we go, tiny little box. And we're going to throw this into a geometry comp just to start setting up our render network. I'm going to go ahead and toggle this viewer off, and I suggest you do that too, just because it will help your computer's performance to not be rendering those instances inside that preview. Also, I need a render top, and I'll go ahead and set this to 1080 by 1080. Also, we need a camera, and let's also create a constant matte that I will drag on top of our geometry and choose material. So get a little white dot here in the middle. Lastly, I'll throw this into a null and toggle the viewer display flag. And just so you guys can follow along, I'm splitting the pane layout up top, dragging this to the left. Where's my mouse? There we go. And let's see, let's toggle the top viewer for the pane type on the left, and on the right, let us toggle off those backdrop tops just so that's not in the background being distracting. So, okay, we've got ourselves our little dot on the left. Next, we need to create sort of a grid of these dots. So the example, there's this like kind of an array of white dots, and they're slightly displaced, so we'll do that a little bit later, but I'll start off by creating our grid. So I'm going to set this to 5 by 5, and the rows 200 by 200, so we've got ourselves 40,000 points. And I'll throw this into a null just because I'm about to go to chops, and so anytime I'm going between data, like this SOP to chop, I'll place a null just for good practice. So now we've got our point positions that we're going to then draw with our instancing method, and I really only need the X and the Y position since Z is constant and I'm not planning on moving it towards or away from the camera. So with this select chop, I'll go ahead and choose TX and TY for my channel names. And then lastly, throw this into a null, rename that instance, and in my geometry, in the instance panel, our page, turn instancing on, and drop it onto our instance chop.sop. Cool. And then we can take our tx and ty and plug that into translate x and translate y, which gives us that nice grid here. Great. So like I mentioned a second ago, the example, the dots were displaced a little bit with random noise to give us kind of more of a random distribution of dots. And so there's different ways to do this, but one technique I learned recently, which I sort of like, is throwing a pattern chop into this sequence. And you'll see that like right off the bat, it's kind of weird because it just is creating a completely different wave, in this case a sine wave. However, if we go to channel and we type in our same channel names, tx and ty, we will see that now we have two channels, and if we, under combine channels, choose something like add, now we are adding our pattern to those input channels. So this is exactly kind of what we want, except in this case, let's choose random instead. And now we've got ourselves randomly displaced points. I'll also bring the amplitude down a bit. We really don't need them to be kind of that out there. So now they're just slightly displaced. And yeah, that's a good starting point. So kind of our next step is we want it to be displacing based on noise, kind of pretty much exactly like my last tutorial on noise displacement and instancing. And so let's go ahead and grab our noise top. This is how we're going to generate that. Let's switch this to RGB format, and I know I'll bring up this period a little bit, but we'll get to a lot of that later. Under the common page, let's make sure we bring this resolution to 200 by 200 so that it matches the grid resolution. So 1 pixel per point, and throw this into a null. And then, as we do, the null will be translated to a different format. So let's go to top to chop. There we go. So there's one row. Under crop, let's make sure we're grabbing the full image. And under image again, we only really want 2 channels here. So, the more channels that you are translating from top to chop, the more this is going to take as far as processing power. And we only have tx and ty, which I can go ahead and rename these. So by reducing the number of channels, we can actually speed up this whole process, make our computer happier. Optimization. So great. So now that we've got our whole channel, like our whole image, each row is its own channel. So to get that into the same format that we have above, we want to shuffle it. Here we go. And we'll choose sequence channel by name. That way tx and ty are their own channels. Lastly, let's go ahead and add that to our positions up here. I grabbed the wrong thing. I want math. And we will plug these in. So we see tx1, ty, ty1, and then go ahead and add these. So we've got 2 chops coming in. That's why I choose combine chops. And there we go. Super handy. So one thing I noticed that I didn't change is we might want to also choose a 32-bit float for our pixel format in our noise, just to give us more resolution for this motion. And speaking of which, we can also get this moving. Later we're going to actually look at looping it, but for now we can just kind of get it transforming to give us an idea of what it's going to look like. So I'll type in abs time.seconds. It's our handy Python expression, and there we go. We've got ourselves some motion in our points. So one thing immediately is you'll notice is that the GIF that we looked at and that we're looking at creating, there's a lot of motion happening in the center, and as it gets closer to the edges, it tapers off to the point that the edges of a circle are not moving almost at all. And when I originally did this, I actually was doing it in chop land, so I my first attempt, I calculated the distance between sort of this point, XY position, and the origin, and then used that to scale the incoming noise. Totally worked, but I realized there's a much easier way to do it if we stay in tops, and that is with a ramp. We will set this ramp to a circular one, and this is what we're going to use to multiply by our noise. So you can kind of think about white is 1, black is 0. So the points that are white, I'm going to set the center to white and the edge to black. The white points is where the noise is going to be most intense, and then it'll taper off based on this ramp. Now we don't want these edges to be white, so we'll choose extend right and hold. That way it just stays black when it gets to the edge. And we also need to make sure we change this resolution to 200 by 200. And we'll also make sure we keep the same pixel format and multiply these together. Great. All right, and there we go. So this is like already starting to resemble what we had before. It's moving maybe a little bit faster. The noise isn't quite the same quality, but those are all things we can tweak. And the last couple things we'll do before we get to that looping trick, that's why you're all watching, I assume, is we want to make sure that we kind of like throw out all of these extra pixels that aren't within the circle. I'll zoom out a little bit actually, because I realize I've been zoomed in a little bit, so now we can see that circular edge here. And when I was first developing this, I was thinking about ways of not drawing these at all, like removing them in the chop phase, which was challenging because I was doing the noise with a grid. So then even if I got the points to a circle, it was kind of a mess. And then I realized, again, do it in tops if you can. So this is an instance where I just take a circle, throw it on the output. I'll adjust the size now so that the radius lines up with my circle. And then I can go ahead and drop the fill alpha, bring up the background alpha, which already is giving me this kind of like cropping effect, and choose a border color if you like, so white in this case, and increase the border width slightly to give us, something that actually looks a lot like the original. So pretty handy way of going about it. The one last thing, if we're going to be true to that example, is it had a little bit of motion blur to it, so I will go ahead and create a slight feedback effect here. So on middle mouse button, or I can even right mouse button, and grab a base, which gives me sort of a place to create my feedback effects. And then double clicking on this is where I'll create my feedback. If I go up, I can actually rename this feedback. And I'll go in here and middle mouse button, create a feedback top coming out of the in. And then right now it doesn't do anything, so we actually need to set a target top. If I go ahead and create a null at the end, oops, there we go, and drag that on top of my feedback, you'll see that now my feedback is updating, and it's actually hard to tell, but it's technically 1 frame difference. So this is like 1 frame back, which is why we avoid cook dependency loops that you might encounter otherwise. I'm also going to grab a composite in the same line. Yep, good. And this could be an over or some other sort of top, but the composite gives you a lot of flexibility as far as how you combine your feedback chain with the kind of like dry signal, if you want to think about it as like dry and wet effects. So grabbing my feedback, I'll do 2 things in this feedback loop. One is blur slightly, and also add a level. So plugging this into my composite, with the over operation, we suddenly eventually just fills up and becomes fully white. And so that's because we are, not dampening that brightness at all. or in this case, we can use the opacity in our level, bring that down a little bit, and now we've got kind of these nice, slightly blurred feedback trails, a little bit of motion blur. If you don't like the sort of washed out quality that happens pretty quick, you can also bring up the black level a little bit. So you still get the blur, but it's like a defined image. It's a little bit sharper, higher contrast. So yeah, this is pretty much the effect that Étienne Jacobs had. So we've sort of recreated at least the look, but the last step is how do we get our noise to start and stop at the same spot. So I'm going to take a quick deviation here and look at this little blackboard diagram that I've generated. So this is a sine wave and a cosine wave being graphed on the x and y axes respectively, and you can see how their intersection, or that point that is being graphed, gives us a perfect circle. If we just took an LFO, which might be your first step if you were trying to loop something, initially, like it definitely is giving us always comes back to that 0 point, but at the peak and the valley, we're getting a point where our speed is approaching 0 as it changes direction. So you would actually see that in the noise. It would speed up and slow down in its change. So really what we need, and why this is kind of a brilliant solution here, is another LFO, another sine wave. In this case, we could set this to 0.25 phase, or 90 degrees out of phase, and if I pulse these, you'll see that now this is actually a sine and a cosine wave because of the phase displacement. And you'll notice that when our LFO1 hits the center, LFO2 is at its peak. So essentially the speed, when our LFO is moving fastest, our LFO2 is moving slowest, and vice versa. So it kind of gets around that issue that we would encounter if we were just trying to loop things with an LFO. And it's giving us, if we look at it, it's actually giving us a circle as far as the motion of those two combined signals, which is why I really like this visualization. So if we go back to our sketch that we've been working on, right now we're just moving our noise through time, and it's not ever going to come back to the same spot. But if we did, to illustrate this issue too, it helps to maybe just look at what happens when you do map an LFO to that value. So if I bring the speed down a little bit, open up the display with A, and then drag this on to export it, you'll see that, oh yeah, we're getting this slow down and stop at the peaks and the valleys. So just to delete this, and we're going to go ahead and do it the right way. So yeah, what we want really is something that, to make exporting it easily, we'll line this up with the timeline so that it's really easy to export as a GIF when the time comes. So in order to generate our sine and cosine values, we're actually going to drive it with the timeline chop. And in this case, it's giving us the frames, so it just counts up to whatever our kind of the end of our animation, or like the end of our timeline. And then we'll also choose range end. So this is giving us 600 because that's our the end of our range. And now to get this into a fraction, we can throw a math chop at the end and just divide those two channels. So right now it needs to be hit A and then R, so we can actually reset the bounds there and see that, okay, now we've got a fraction counting up from 0 to 1. So great, now we need to use that to drive our sine and cosine. So what we'll do is create two patterns, pattern chops. So the first one is a sine wave, and I'll change this channel to TZ because we're going to be changing the Z axis, and then also create a corresponding cosine and call this TW because we're going to be changing the W axis. X, Y, Z. W is sometimes used for that fourth axis. And then lastly, merge these together and we want to use this fraction to cycle through the samples in, just move through those sine and cosine samples. So to do this, we can use a lookup chop, and now we've got smoothly moving, sine and cosine that are directly linked to our animation length. So that is going to be handy when you actually want to export this and know where it starts and stops. You could do this the way I just did with LFOs, but then it gets a little bit challenging making sure that your frames line up with this actual motion. Cool, so we've got our movement shape. The next thing, I'll throw this into a null, is we want to export this to our noise. And right now we don't quite have our noise in a position to do this. We have our Z axis that we can translate in. However, the X and the Y, if we did export these sine waves, we would still see that motion as it got to the edges of the signal. So in this case, we're going to change the type to our simplex 4D. And why this is great is it gives us a fourth dimension to translate the noise. So you can kind of think about it as instead of just having 3 inputs to translate it, we just have this fourth that behaves very similarly to the translate Z. So I'll go grab my null, hit A, so that I can expose those exports, and I'll drag TZ onto translate Z, and TW onto translate 4D. And now we've got ourselves a smoothly moving noise that's completely generated and kind of like moved by the timeline length. And it's interesting, you'll see if we increase or decrease the length of the timeline, it actually directly changes how fast this noise is moving. So something else you could do is add a math in here and use that as like an additional way to scale how intense that noise is. Multiplying it will give you, basically if you increase the range that it moves, it's going to increase the amount that it translates. So yeah, there you go. We've got ourselves our noise that essentially loops. So the last step, you might want to actually export this, and so some of you might not be familiar with how to do this. So there's a movie file out, and this can be really useful for capturing your TouchDesigner videos. One thing that took me a long time to realize is there's this real-time flag at the top, and when you're exporting video, if you can get away with it, like if you're not taking in real-time sensors and inputs, definitely toggle it off. That way, if there are any, if your computer is taking more time to render a frame than your frame rate, it'll still render it cleanly without any hiccups. It'll just wait to the next frame to write the next frame. So super useful. You can get away with even exporting animations that normally would be running at 3 or 4 frames per second. I've sometimes done this for just animating things in TouchDesigner and trying to push the quality beyond what I could do in real time, which is an atypical use of the software, but certainly a use of the software. So definitely know when to toggle this real-time flag off. And then you can choose your video type. So something like a GIF is how you might embed it on a website, or H.264 if you're going to upload it to like Vimeo or YouTube or Facebook or Instagram. You could use HapQ or animation if you really want really large, high quality video. So a lot of different things here, but you can choose GIF if you want to make a looping GIF. A couple things before you would record. One is click this once and let it stop at the last frame before you continue. That way when you go back, you start the animation, that feedback that's building is going to be based on the last few frames, so your feedback is also going to be looping. If you jump from the middle, you'll actually see weird stuff happen with your feedback because it's going to be, the beginning of your loop is going to have some feedback from the middle of your loop, and that won't necessarily look continuous. So then the process would be, click on this plus to name your file. I'm not going to record it because I'm also recording 2 videos now, so it might throw my computer off, but you would then click record, and then when you're ready, click loop, and it'll just record probably in real time or close to it. And then when you're ready for it to stop, click once again and wait for it to get to the end of your timeline. And then toggle off your record. So that's how you would get a seamlessly looping GIF or animation out of TouchDesigner based on looping noise. So this is, again, the first part in a series that will cover similar topics about using noise to loop in different ways. I hope you kind of got something out of this one, learned something new in the software. Thank you for watching, and until next time.